Today about polynomials, right? What's about just sort of what it means to be a polynomial. We've alluded to this in the past, and it's nothing really very surprising. But what does it mean to be a polynomial? Poly means many, and so polynomial just means many terms. Polynomial is the sum or difference of many monomials. Each term in a polynomial by itself we could consider to be a monomial, right? And so all the properties of monomials that we discussed last time would apply. What are the ingredients of a polynomial? The polynomial has powers, right? It has variables to powers, and it has coefficients. So just in a nutshell, what has to be true for something to be a polynomial? Coefficients must be real, remember we said. So they can't have imaginary parts. That's one thing that has to be true. And the other thing is exponents must be whole numbers. So they can't be fractional, can't be negative, okay? All right, so the highest exponent of a polynomial is called the degree of the polynomial. And the standard form of a polynomial just says that we're going to write the terms in decreasing order of power. So the biggest exponents always come first, okay? Okay? So for example, these are all examples of polynomials here. Let's take that top one. If I want to write this in its standard form, in its organized way, which is important to do, which term would have to come first? Yeah, it's got to be that one, right? The biggest power of the variable k. So this is going to equal negative k to the fifth. So that one goes first. Then which one? Okay, good. Then I've got to do the minus 3k cubed. And then I've got to do the k. You get the idea, right? Then I've got to do the k squared. Then I've got to do the k. And then finally, I've got to do the constant, because the constant is times k to what power, essentially? 0. Yeah, okay. There it is. Okay, what about 11? How are we going to organize 11? Yeah, think about that one for a second. Everybody think about how you might be able to organize that one. There's different ways you could, but see if your intuition is going to tell you how we should do that one. How do we organize variables? Like if I have y times x times z, how would I write those? Alphabetically, right? We always want to organize our variables in increasing alphabetical order. And so we would take the first alphabetical variable and we would base it on that, okay? Now there's a little bit, that could be disputed though. I'll talk about why I might question this one a little bit. This is the way that our book is teaching this, and it's fine. Very seldom do you ever run into this issue anyway, because almost always when we're doing polynomials, well, we're going to deal almost exclusively with polynomials of a single variable when we're actually doing analysis, right? We're just practicing understanding what a polynomial is and what the rules are with multiple variables, but seldom do we really do a lot with that in this class. So we would say that because this is the highest power of a, it's going to go first. So 4a cubed, Then we've got the next highest power of a. What if I had an a squared times a b squared and I also had an a squared times a b? Which one would go first? The one with the higher power of b would go first, right? Does that make sense? Okay, so plus 18 a squared b squared. And then I've got a single power of a. So I do that one next. And then finally, I've got one with no a's in it. So it'd be that way. Can anybody think of another way I might reasonably think about organizing those? What do you think, Maria?
I put the b squared before 7.
You put that one before that one?
No.
Before that one. Okay. Okay. I would say that those two should always be in that order. Okay. Because if I look at the combined power of the exponents, this is a to the 1 times b to the 1. So the combined power of the exponents is 2, and the combined power of the exponents there is 2. But look at these first two. I would say that in certain circumstances, I would exchange those. How come?
Because the powers are equal to 4 on it.
There you go. Yep, exactly. So another way you could do this that's very reasonable is you could say, what's the combined power of each term? And whichever term has the highest combined power, that's going to go first. Now, if multiple terms have the same highest combined power, then we would defer to, A's come before B's. Does that make sense? Okay. But oftentimes, I can remember many times you work with polynomials in college and beyond where when you're doing lots of work, it's nice to have these things organized so that you've got the highest combined powers first. So I could see those two being interchanged. Is it a big deal? Not really. Not really. So how about this bottom one down here? What would we do with this guy then? What definitely would be the first term? Yeah, that one would definitely be the first term. It's got the highest combined power and the highest power of x, right? So 9x cubed y. Okay, by the method that they're telling us here, if we're just going x's first, then the next term should be minus x squared. That kind of bothers me a little bit, right? Minus x squared. Then we would do this term. Now, finally, we get to terms with no x's. And then that term would go first, right? But in my opinion, I would probably almost always do it this way. What would I put next? Negative y to the fourth, right? Because that's a bigger power. And then we move down to, then this guy has a combined power of 3, doesn't it? Okay, so we could do, then we do our minus x squared plus 2. So this is the correct answer, but this is a reasonable way to represent that polynomial too when you're doing work sometimes, okay? I don't want to get too hung up on that stuff, not a big deal. So when we talk about polynomials, we want to be able to classify them. And this is not probably as big a deal as it sounds either. So the degree of the polynomial, because we work with polynomials so often, they're such a big part of what we do in math, they get names. They get names. Some of these things, we use them so often that we name them. If we have a 0-degree polynomial, what do you think that we're going to call a 0-degree polynomial? If the biggest power of the variable is 0, what does that sound like? Does the variable even show up? No. Whoops. So this we just call constant. Okay, because there's no variables that even show up. Only constants would show up. Okay, what if the degree of the polynomial, the biggest degree, or the biggest power is 1, so the degree of the polynomial is 1. What kind of equations does that seem like that would correspond to that we've dealt with? Linear, right? That would be something like mx plus b, wouldn't it? Right? Because the biggest power of x is 1. So a first degree polynomial we'd call a linear polynomial. Now maybe you're seeing the pattern. What would we call a second degree polynomial? We've dealt with these too. Quadratic, yeah. That would be something like ax squared plus bx plus c, wouldn't it? Right? So now just extend your thinking. What would a third degree polynomial probably be? What kind of an equation does that become? What, say it again? Cubic, yeah. Cubic polynomial would be one where the biggest power is x cubed. Anybody know what fourth degree would be? That's probably a new one. It's called a quartic polynomial. And fifth degree is a quintic. Do you ever use the word quintic? No, not really. I probably said that word about 10 times in my life. You never say it. Quartic you'd say quite a bit, but quintic, you can also just say fifth degree polynomial or 10th degree polynomial or second degree polynomial. To me, anything above 4, you wouldn't really call it anything. Up through 4, probably we'd say those words, but that's it. Okay, so that's one way we classify polynomials is by degree. The other way we classify polynomials is by the number of terms. Okay, well, what do we call a polynomial with a single term? Monomial. Monomial. What do we call a polynomial with 2 terms? Say it again. Binomial. There you go. What do we call a polynomial with 3 terms? And we used to factor these quite a bit last unit. Trinomial. There we go. And if it's got 4 or more terms, we just call it a polynomial. Poly meaning many. Okay? So let's classify these things then. What would I call 13? I want to classify it by degree first and then by number of terms. Linear binomial. That's it. How about number 14? Quintic trinomial. There you go. $15. Constant monomial. $16. Cubic polynomial. $17. Everybody agree? Quadratic trinomial. Okay, good. Good. And finally, 18. Quartic monomial. Good. Okay, everybody write down an example of a cubic binomial. Cubic binomial. Jace, what'd you get?
10x cubed plus 25.
There you go. How about a linear monomial? Carrie, can you give me a linear monomial? You said 5? Okay, 5. But if it's, so that's a monomial, but if it's going to be linear, what's the power of x need to be? Okay. So like 5x. Okay. All right. Okay, before we jump into adding and subtracting, I want to just see. Let me look at the assignment here. I don't think there's anything that big a deal that we need to go through, but I want to just take a quick look. Oh, is the properties of exponents assignment not showing up for you guys? Should be now. Okay, now it's showing up. Whoops. Pick a tricky one here. I think, oh, there's a good one. Okay, how about that? Is it a polynomial? And if so, what's the degree? How do I make that thing go away? What did I do? Has that thing been there the whole time? I didn't think it was either. That's kind of a pain. I don't know why it's there. Can't get rid of that stupid thing. Oh, well, so we won't worry about it. So what do you think? Is it a polynomial? Does it fit the criteria? Thumbs up, thumbs down. Yeah, thumbs up. It works. What's the degree? 9, I'm hearing. Anybody else got a different answer? 14. Yeah. It's 14. So it is a 1, 2, 3, 4. So it's a polynomial. It's none of those, right? And the degree should be, how come it's 14? Okay, because the highest combined power of the variables is 14. Okay, make sense? Okay, let's try another one. Let's try. Okay, what about that guy? Is that a polynomial? Okay, it's not. How come? What rule did it break? Okay, look there. If I wrote that as an x to a power, that'd be x to the -7, wouldn't it? -7 is not a whole number. Okay, so that is not a polynomial. Whoops. Okay, let's try another one. What's the degree of that term? Okay, good, 10, because I've got a to the 1 times b to the 4 times c. Everybody see that? Okay. Yes or no, polynomial? Nope, I got a fractional exponent. No good, right? Okay, I think you got this. This is not a big deal. Anything else here? Let's go down to the bottom. Oh, there's a tricky one. Let's do that. How about that one? Is that a polynomial? Thumbs up, thumbs down. What do you think? Ooh, we got a debate here. Thumbs down. What's the problem? Okay, so I could rewrite this, couldn't I? And that's probably the where the questions arise is. The way it's written, it looks funny, but I could write this in standard form of a polynomial, couldn't I? Because if I were to separate that common denominator, I end up with 9 over 9 is 1, and the other term is just a -1/9. Let me write this down so you guys can see this. Okay, I could write this here. I could split this up into 9 over 9 minus x cubed over 9, which is 1 minus 1/9 x cubed, which I could write in standard form as minus 1/9 x cubed plus 1, right? That's a polynomial, isn't it? I've got real number coefficients and I have whole number exponents. So that actually is a polynomial, okay? All right. Okay. Adding and subtracting polynomials. Adding and subtracting polynomials is just as easy as you would think it is. All you're doing is combining like terms. That's it, okay? So let's take a look. I want to look at, what do I have up here? Okay, so let's take a look at a couple examples of this. Let's just look at number 2 and number 4. How about? So our goal here is to combine these polynomials and write them in standard form. Oh, darn it. Forgot about that. All we're doing is combining like terms. No big deal, right? You guys can all do that. I've got a plus sign there. Do I need to do anything to those parentheses, or can I freely remove them? Can I freely erase them? I can remove them, right? Because they don't do anything. There's nothing that's being distributed, and we're not taking it to any power. Agreed? So they're not serving any purpose. I can just erase them and combine like terms. Easy to do. Now, when you're adding up polynomials, especially if you're adding up a whole bunch of polynomials, I'm going to show you a little trick for this. If you're just adding up 2 simple polynomials like that, then just no big deal. But if I had a whole bunch of polynomials with many terms and higher exponents, right, higher degree polynomials, then sometimes it's useful to add these things up using columns. Okay, so if I wanted to add these up using columns, I would say 9n cubed, and I have to have a column for every power of the variable, okay? Because I need to be able to line up all the like terms. And so, like, for example, if this first polynomial was missing that 4n squared term, I would leave a space there, right? Because other polynomials that I'm adding could have n squared terms, okay? Plus, and then I'll just line this one up vertically, so each term lines up vertically with the term above it. You see how easy it is then to add these things up. I mean, if you had a whole bunch of them, it's really no harder to do. But if I have a whole bunch of polynomials that I'm adding up horizontally, it's hard to keep track of the terms. Which ones have I already added, right? Can you see a practical advantage to this? So I'd have a negative 2n squared plus n plus 7, and now all I got to do is add vertically. So I get 9n cubed minus 6n squared plus 3n minus 3, and I'm done. Okay? Same kind of thing for subtracting. When we subtract polynomials, there are different ways you could do this, but I strongly recommend you distribute the negative sign and add. So for example, let's do this guy right here, number 4. How about? Okay, so if I wanted to subtract these things and I want to do it vertically, if I don't want to do it vertically, I'm just going to distribute the negative sign and add horizontally. But if I do this vertically, I would end up with...
Attention Buckaroos, I need the following 4 students to please bring their senior scripts down to the athletics office. Travis Miller, Johan Malaria Vegas, John Moreno,